Okay, we're at part 175, line 18A, 3z5b2 Polarized laser light optical rotation argon gas, wave metastable atoms 5G Wow Seti. Here's the radio signal, and that's the number we Google. So today's date is April the 11th. At 10:28 p.m. and these notes were done on March 22nd. And I'm just going to adjust my camera here. Oh, can't. Okay, so March 22nd, 2012, my thoughts. The keywords from The Arrangement of Atoms in Space, 1874 to 77, by Dr. J.H. Van Hoff. It says, rotate the plane of polarized light. Okay, using the formulas and a beam of neutrino light, can we rotate the plane of polarized light and cause its collisions to increase faster than the speed of light? So I'm going to Google rotate the plane of polarization of light to see what happens. And this comes up. Quote, optical rotation, optical activity, is the turning of the plate of linearly polarized light about the direction of motion as the light travels through certain materials. It occurs in solutions of chiral molecules such as sucrose, sugar, solids rotated crystal planes such as quartz, and spin polarized gases of atoms or molecules. My thoughts continued. The keyword here is spin polarized gases of atoms or molecules. What happens when you spin polarized liquid argon gas with neutrinos and lepton? The keyword spin has come in the Wow Seti data several times. It's always mentioned with neutrinos splitting after colliding and along with fermions and leptons. This must mean something when all of them keep coming up with one another in the Wow lines of data. So I'm going to Google spin polarized liquid argon gas, and this comes up. Spin polarizing particles like argon, helium, and neon using laser optical pumping. So it's a thesis. Laser-induced optical pumping from Carl Willard Giberson. The abstract says, optical pumping is a very useful technique for the production of spin-polarized particles. This thesis describes laser-induced optical pumping in helium, argon, and neon metastable atoms. The laser used to optically pump helium is a F2+ color center laser, which was developed during the course of this work. Argon and neon were optically pumped with commercially available dye lasers. In the first experiment, the color center laser was used to spin polarize a Doppler broadened ensemble of He2 3s metastable atoms contained in a flowing helium afterglow. The extracted chemi-ionized electron polarization was at as high as 80%, indicating almost complete polarization of the two 3s atoms. A P2 I quality factor of 8 times 10 minus 6 was obtained. The next set of experiments involved the optical pumping of metastable atoms contained in columnated beams. Although substantial polarizations were achieved, problems were encountered with laser frequency jitter, as none of these lasers were frequently stabilized. In particular, the polarizations obtained in both helium and argon were unstable, and not even a nominal polarization could be maintained consistently over any reasonable time interval. Stable optical pumping in neon was obtained with the DCM dye laser, however, due to frequency jitter, which essentially broadened the narrow spectral components in the laser line shape. In an effort to improve on the limited performance obtained in the optical pumping of both helium and argon, a frequency modulation technique has been developed. By decomposing the very narrow spectral components present in typical laser radiation into a large number of closely spaced sidebands, this technique effectively fills in the gaps in the laser line width. This broad, continuous line width enhances the ability of unstabilized lasers to optically pump very narrow atomic transitions by reducing the effects of laser detuning. In an initial experiment, almost complete polarization of a beam of argon. Sorry, my arm's getting sore here. Beam of argon metastable atoms was obtained using a frequency modulated LD700 dye laser. The polarization was stable on a time scale of several hours, more than adequate for proposed spin-dependent studies. From 1985. Here's a graph that says the reflection coefficients are different for waves parallel and perpendicular to the plane of incidence, and there's Brewster angle. This is reflected intensity of rays parallel and perpendicular to the plane of incidence. That's Brewster's angle. I'll pull it back again here. When light is incident at the Brewster angle, the reflected light is linearly polarized because the reflection coefficient for this two component is 0. And some hyperphysics.ph-astr.gsu.edu. March 22nd, 2012. My thoughts. What if you use obsidian sphere glass mirrors as your reflection coefficients for this wave-light experiment? Can this be used to create nuclear fusion at all? And then, just so you know, line 18A3, line 18A3Z5 has sections A all the way to B6. So we've got 8 videos from this. What happened is I found a bunch of data in this one video and I broke it down into 8 mini videos. Okay, so these are the labels of the videos that you'll be looking for. They will be linked together on YouTube, The Idea Girl Says. They will eventually be blogged on the Victoria Stafford A Psychic Investigation on WordPress, where I blog the research notes that come up with the links so that you can look at the stuff more. And because I only do little portions of each thing that I find, and I leave the details for you guys to look at. So this is line 18A3Z5b. Uniform convergence to Tetrahedra, Isomer, Hydrocarbon cracking 5G Wow Seti. That was the first video. The second one was this one that we just did. Line 18A3Z5b2 Polarized laser light optical rotation argon gas wave metastable atoms 5G Wow Seti. The next video we'll be doing is line 18A3Z5b3A nuclear fusion collision spin polarized plasmas electron heating velocity 5G Wow Seti. The next one will be called line 18A3Z5b3B. Tetrahedrite, Quark, sorry I don't know how to say it. Quark wafers, CBD, thermal spraying, plasma 5G Wow Seti. Next is line 18A3Z5b3C. Tetrahedrite, crystal skulls, cubic, matrix, resin, copper foils 5G Wow Seti. Line 18A3Z5b3D is atomic F shell complex numbers. Interval cutting tensor 5G Wow Seti. Next is the line 18A3Z5b4. Stern-Gerlach spin nuclear fuse polarized fuels Coulomb barrier 5G Wow Seti. Next we're going to do line 18A3Z5b5. Coulomb barrier nuclear bisphere fiber laser light resonators 5G Wow Seti. And then the last part for this particular line of data is line 18A3Z5b6 NASA plasma powered UFO technology electromagnetic 5G Wow Seti. The tags that I'm going to tell you, the words that we'll be talking about, is columnated beams, actually I'm just going to let you read it. It's easier that way. Save my voice. I got 8 videos to film here. Okay, so these are the words we're going to be looking at. I look at keywords in the videos and I make my little tags up out of what's talked about in the data we have coming up with the Wow Seti signal. Again, this is video 175. So there's 175 videos before this one that you want to look at if you're looking at this whole series here, okay? When I say there's a series of 8 videos, it means that one piece of data was broken down into 8 segments because there was so much and I didn't want the video to end up being 40 minutes too long. I had videos getting up to 30 or 40 minutes long and I try to keep them around 10 or 15 minutes because people like to look at them on their breaks, okay? So that's the end of that one.